This is 1-7 absolute value equations and absolute value inequalities. Just as a reminder, absolute value, the definition of that is the distance from zero on a number line, the distance from zero. So just this first example, just to remind you, the absolute value of 3 on a number line. So here's what a number line looks like. And so here's 0, here's 3. So notice it's 3 spaces away from 0. So the absolute value of 3 is 3. So the absolute value of -8. So let's look at this one. Well, again, think on a number line. How many spaces is the absolute value of -8? How many spaces is -8 from 0? Well, it's 8 spaces. Remember, distance is always positive. When you take a tape measure out, there are no negative numbers on there. It's always positive numbers. So the absolute value of -2.4, again, the distance from 0 to -2.4 on a number line is 2.4. Distance is always positive. This one, the absolute value of 0, well, how many spaces is it from 0 to 0? Well, it's 0. The absolute value of 5/8 is 5/8. All right, those are just reminder problems. So here what we're doing is solving this absolute value problem. And if you just imagine for a second, that's just plain x. So we would -2 from both sides, -2 from both sides. And we're going to get the absolute value of x is 5. Remember what absolute value means. It's the distance from 0 to 5. So think on a number line. The distance from 0 to 5, well, we know 5 is here, and that's 5 spaces away. But so is -5 is 5 spaces away. Remember, the absolute value means distance. So the distance is 5. That means the answer actually could be 5 or it could be -5. Because -5 is 5 spaces away from 0, and so is +5. So absolute value, you're going to see that there's going to be 2 possible answers. It actually could be a positive or it could be a negative. To be able to find the definition, again, is the distance from 0 to that number. So let's look at this. Again, this inside value is, when I take the absolute value of it, will equal 1. Well, this inside value could be 1. So in other words, the absolute value of 1 is 1. But so is the absolute value of -1. So this inside value could be 1. Or this inside value could be -1. So you're always going to think of that inside value could be this, could be 1, or it could be -1. The inside value could be 1, or it could be -1. So you're literally going to take that inside 2x minus 3, and you're going to set it equal to 1, and you're going to solve. And then you set it, the inside value could equal to -1. So you're going to add 3 to both sides. And so x could be 2, or it could be negative, or it could be +1. So when you're solving this, don't just solve it and then say, oh, x is 2 and -2. That's a common mistake I always see. Students solve it and then they say, oh, 2 and -2. That's not what absolute value is. Again, the inside value could be 1, or it could be -1. So, and if you check this, so if we actually check this problem, so x equals 2. So if we put 2 inside of here, so that's 4 minus 3, which is 1. The absolute value of 1 is 1. So let's check 1 right here. So if we put 2 times 1 inside the absolute value, that's 2 minus 3, and that's -1. Well, the absolute value of -1 is +1. So this checks and this checks. You can always plug them in to see if they actually do work. All right, so this problem right here, remember on the previous couple of problems, once I have this, absolute value equals a number, then I know the inside value could be positive or it could be the -1, either one of those. So, but to get to that point, I first have to start solving it like a normal equation. So I'm going to add 8 to both sides. And then I'm going to divide both sides by 3. Don't be tempted to use the distributive property. These are not parentheses. They are not parentheses. So don't use the distributive property like parentheses. They are merely just absolute value symbols. So here the 3's cross out, and you're left with x plus 6, the absolute value of x plus 6 equals 1. Now I know, because of the absolute value, I know that inside value, the inside value could equal 1, or the inside value could equal -1. And then you just solve this. So again, what we're not saying that what you learned earlier. You always think, oh, it's always got to be positive. Well, the absolute value of something will always be positive, because remember, the absolute value means the distance on a number line is 1. So this is 1 space away. That's from 0. That's what that means. So it doesn't mean x can't be positive or negative. It doesn't mean that. So if I substituted -5 into this original problem, if I substituted -5 in there, or if I substituted -7 in there, both of them will work out to be able to equal -5. And again, if you take -5 and put it right there where x is, or if you take -7 and put it right there, again, and then work the problem, it will equal -5. You can check your answer to do that. So let's look at this problem. Very similar to the last problem, very similar. But I want you to notice, if I start solving -8 from both sides, I'm going to get this. Divide both sides by 3, just like last problem. Now here's something you need to literally pause the video and think about this. Because remember the definition of absolute value. The definition says the distance from 0 to that number is got to, and remember, distance is always positive. Distance is always positive. So this right here is saying, hey, when will this absolute value ever equal a -1? When will distance ever equal a negative distance? When can I ever pull out my tape measure and get a negative number? You can't. This is an impossible. So whenever you work a problem like this, you get down to the absolute value equals a negative number, which is impossible. The absolute value cannot equal a negative number. What you have to do is just say there is no solution. There is no x value ever that will ever make that positive or negative. So if you try 5 in there, or 23, or -77, or whatever it is, once you take the absolute value of it, the absolute value makes it positive. So it doesn't make a difference what I put into there. These absolute values will always make it positive, which it cannot equal a -1. There is no way that that's an answer. So you just have to notice that. And again, just because you see it equals a negative number, don't automatically think it's no solution, because I proved it on this one. There is a solution. You have to work it down to nothing but the absolute value. Once you get it down to nothing but the absolute value, if it equals a positive number, then you can solve it. If the absolute value equals a negative number, it's impossible to solve. Just like this one. Again, absolute value cannot equal a negative number. So let's consider inequalities for a moment. So again, this means the absolute value of x is less than 3. That's what that is. But remember, I keep saying this, the absolute value means it's the distance from 0 to the number that we're referring to. So in this case, we're talking about, if you think of this as a number line, we're talking about that x. We don't know what x is, okay? But we know that the absolute value of it, the distance, has to be less than 3. So, here's 3 spaces away. Here's also 3 spaces away, okay? But it has to be less than 3. Again, the distance, whatever x is, we don't know what x is, but the distance has to be less than 3 spaces away. So it has to be somewhere within this range. And so we don't really know what that is. We don't know what x is, but we know it's within that range. So it's somewhere in between those two values. So that literally is x is less than 3, and also x is greater than -3. So we talked about the different inequalities, so that x is in between those scenarios. So that literally can be written like a compound inequality, like that. So this is really the same thing as that. That's really what that is. Remember, the distance of whatever x is, it's got to be less than 3. The distance has to be less than 3 spaces away. Now on this one, the distance is got to be, again, think of, we don't know what x is, but the distance, this is distance. The distance is greater than 3. The distance is greater than 3. That's what that means. It's greater than 3 spaces away. So it could be 3.5, it could be 4, it could be 20,000. I mean, whatever it is, the distance has to be greater than 3. So we're talking about anything that direction, or again, anything distance-wise. You know, it could be referring to that way, because again, the distance from 0, you know, it could be -4, -5, or -6. It's anything that direction or that direction to be able to do that. So this literally is x is greater than 3, or x is less than -3. So this means the same thing as that.